What's the date today? This is 5,
It's a
7. Wow. Segment relationships in circles. Boy, you better not be talking while I'm trying to teach. Son. If two chords intersect inside a circle, if two chords intersect inside a circle, then the products inside a circle, then the products of the segments are equal. Then the products of the segments are equal. And move that up there. So you can just kind of look at the picture there, and it's a really good explanation of what's going on. So you got a circle, and let's say red chord intersects with blue chord. And as you can see, they intersect inside the circle. So if this point is A, E, B, and then CD, what the theorem says is that CE times ED is going to be equal to AE times EB. So if you put a X right here and an 8 and a 6 and a 4, then 8 times X, or 8X, is going to equal 6 times 4, which is 24. Divide both sides by 8. X equals 3. Clear? Doesn't look too overly difficult, does it? Good. All right, so look at the theorem on the next page. 12-6-2. Let's see if we can cut the words down maybe. If two secants intersect in the exterior of a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So we're just not going to write that theorem down. We're going to draw the picture. Because they say a picture is worth like 7 words, right? Good. So let's say now you got red secant and blue secant. And now they intersect outside the circle. It's basically the products of each of the pieces are equal. So AB times BE is equal to what? CD times DE. Clear? Does anybody need to see an example? Let's see here. Did I do that? Did I write that down right? A to E. Oh. No, I didn't write that down right. That would have been too easy to be true. So just erase that. Hopefully you're not writing in pen. And it's actually this. It's AE. So it's the sum of these two pieces. It's AE times BE equals this entire blue piece, which is CE times DE. So it's the entire secant, the length of the entire secant times this outside piece, right, is equal to the length of the entire other secant times its outside piece. So that makes it a little more complicated, doesn't it? So let's do a 5 here, and an X, and then a 4 and a 6, and we'll see what happens here. Let's do a 4, 6, 4, and 6. So 4 plus 6 is what? 10. 10 would be the whole piece, so you would have 10 times the outside piece, which is 6, equal to, what's this whole piece? 5 plus x, right? Or x plus 5 times the outside piece, which is x. Yeah, and I did this different than the example, so, oh well, it'll still work. So what's 10 times 6?
60.
Good. And now you got to do distributive property here, don't you? So what's x times x? X squared. Oh, I made a mess here, but we're just going to finish it anyway. And what's 5 times x?
That's 5x.
Anybody remember how to solve anything like that?
I think I do.
Yes, ma'am. You set it equal to 0, so you subtract 60 from each side. So 0 equals x squared plus 5x minus 60. Anybody remember how to solve that? First thing you would try to do is factor it. Two numbers, are there any two numbers that multiply to negative 60 and add up to positive 5? What are the factors of 60? You got 60 and 1, right? You got 30 and 2. You got 20 and 3. 15 and 4. 5 goes, doesn't it? 12 and 5. 6 and 10.
That's what I got.
7, 8, 9, or 10 don't go. And now you're back at 10, right? So aren't those all the factors, the whole number of factors of 60?
Yeah.
Can you add or subtract any of those two pairs and get a 5?
Well, 20, 50.
No, you have to combine them this way.
Never mind.
12 and 5 gives you a 7 or a 17, right? 10 and 6 gives you a 4 or a 16. This gives you a 19 or an 11, a 23 or 17. None of them work, do they? Okay. So this was a really bad example for me to give you because the book switches the 5 and the x and the 6 and the 4. But this is what you'll learn in Algebra 2. You'll learn how to solve that. You'll use the quadratic formula if you can't factor it.
Yeah, quadratic, well, that's what I was.
Yeah. So you'll go like what? X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a.
2A. Yeah.
Right? So in this case, your a would be 1, your b would be 5, your c would be negative 60. You'll plug it in, you'll solve it. In this case, you would probably get, usually when you do the quadratic formula, you get a positive and a negative answer because of the plus or minus portion. So you would only use the positive number. Okay. So those of you that wrote in, let's just do another one. So we're going to leave that there. I'm not finishing that. Let's put the numbers where the book put them. And so let's see. The x and the 6 are on the inside.
Wait, are we doing another one?
Does it look like we're doing another one?
Hey,
And there's a 4 that goes with a 6, and there's a 5 that goes with the x. All right, so we'll try it again. We got the entire secant is 10 times 4, right? 10 times its outside equals the entire segment, x plus 5, times its outside piece, which is 5. So 40 is going to be equal to x times 5 is 5x, and 5 times 5 is 25. So this will be a little cleaner, as you can see. So
Divisible by 5.
subtract 25 from each side. 15 equals 5x, and then divide by 5. And x equals 3 again. You're just going to have to pay attention to where the chords, where the intersection point is. When the intersection point is on the outside, it's the whole piece times the outside piece equals whole times outside. When the point of intersection is inside, okay, it's the length of each segment. It's the product of each segment. Got it? Anybody got any questions? Anybody want to see? Let's do one more example. Look, page 842. Another very wordy theorem. Then you can copy that theorem into your notes if you want to. Or you can just draw the picture. I'm going to draw the picture. I think the picture is easier to remember anyway. This looks like a secant and a tangent. So red is going to be the secant, and then blue is going to be a tangent. And these are labeled A, B, C, and D. So I'll read it. If a secant and a tangent intersect in the exterior of a circle, then the product of the lengths of the secant segment and its external segment equal the length of the tangent segment squared. Tangent segment squared. So in this case, all right, it intersects on the outside again, so it's going to be the entire secant, which is AC, times its outside piece, BC, is going to be equal to the tangent piece squared. So that's going to be DC squared, all of it squared, the whole segment squared. So you got a 4 again, and then an outside piece, nope, don't write that there. On the red piece, inside you got a 5, and on the outside you got a 4. And then your tangent is x. So AC segment AC is 5 plus 4, which is 9, times the outside piece, BC, which is 4, is equal to the tangent piece squared, so x squared. So 36 equals x squared. And if you square root or radical each side, then 6 equals x.
Yeah, I get these results back.
Anybody got any questions? All right, so here's some practice for you. Start on page 843. And you can do 2 through 4, 6 through 8, 9 through 14, and then just do 16 through 21.
Right.
And William, you can do all the way through 39.